In this class, we're going to consider how you solve simultaneous equations, or sometimes they're referred to as systems of equations. In the examples we're going to look at, we're dealing with just two equations, and if you're just starting this topic, that is where you should begin. You can extend that to 3 by 3 systems, where you'd have 3 equations and an x, y, and a z, or even 4 by 4s, etc. But they start to get horrible and complicated, and this is perfectly fine to be getting on with when you're just starting. These, in fact, those techniques are beyond the scope of kind of this work here, and they're a lot more complicated to solve. So you'll be dealing with these 2 by 2 systems, which we usually just refer to as simultaneous equations. They're simultaneous because they're happening at the same time, but more importantly, we're solving them for the same solution for both. So we're looking for an x and a y value that satisfies that equation, but also that one. If you've got 2 variables, an x and a y, but only one equation, so if you just had that there, you can find infinitely many solutions to that. You could put any value in there for x that you want, and you'll be able to find some y value to make 3. So it's not that there's no solutions, it's that there's too many solutions. So we need the second equation to give us that second constraint on the solutions. So it means that you're then going to get a unique solution pair. So an x and a y, one pair, one x value, one y value that satisfies both equations at the same time. So the technique we use for this is called elimination of a variable. And basically it means that we're going to get rid of one of the variables to give us a normal linear equation, which we could just solve by normal equation solving. So what we do, we look at the coefficients, so the numbers in front of the letters. So we've got a 4 and a 2, and this is a 1, and this is a -1. And we look for the pair that are kind of matched up, but we ignore the sign. So this is a 1 and a 1, even though it's a plus and a minus, we kind of ignore that. That means we're going to focus on eliminating the y's. And what we're going to do, we're basically going to work in columns, and almost imagine this as being like a, I don't know, like a sum, almost like a sum that we're working in columns and keeping track of our working. So all we're going to do is try to eliminate that column there to get it to go to 0, in other words, by either adding or subtracting. And in this case, to get that to go to 0, we would need to add, because if you do y plus minus y, well, that's just y minus y, which is 0. If you did y minus minus y, well, a minus minus is a double negative, a plus, so that would give you 2y, and that's not what we want. We want it to go to 0. So we're going to choose to add. That's always your first step, deciding whether you need to add or subtract your 2 equations. So we're going to add them and add them in the column. So 4x plus 2x gives us 6x. These guys go to 0. We're just going to leave that. You don't need to write in the 0. 3 and 9 gives you 12. Now we've eliminated the y. We've got one equation with one variable. Now it's just a normal linear equation. We can just solve by dividing both sides by 2, and we would get x equals, dividing both sides by 6 to get x equals 2. It's already one step ahead of myself there. So x equals 2 is the first solution. So that's the x value. To get the y value, we're just going to take that solution and substitute it into one of the equations. It doesn't matter which one you substitute it into. It really doesn't matter. Whichever one appeals to you. Let's maybe go for, let's call these equations 1 and 2, and we'll substitute it into equation 1. So we're just going to substitute x equals 2 into equation 1. If you substitute into the other equation, you should get the same solution. So 4 times x, well, that's now 4 times 2, which is going to be 8, plus y equals 9. So plus y equals 9. So that tells you that y has to be 1. And that's our second solution. So that's how we do it. Not too difficult, just a few lines of working. But the key is that these were already matched up, okay? And some of the questions like this one here, which we're not going to fully explore in this class, we're just going to get started with, you need to think about the fact that these are not matched up, which is a more difficult scenario. Let's have a look at the second one. We can see in this example, it's the x's that are matched up. And we can see that to eliminate those, because they're both positive, we would need to subtract. So we're going to subtract our 2 equations this time. It's quite good practice to label your equations 1 and 2. You don't have to do that, but it helps keep track of where you are. So subtracting this time in the columns, 5x minus 5x is 0, 4y minus y is 3y, 22 minus 13 is 9, and then we've just got a linear equation to solve. Divide both sides by 3, and we get y equals 3. This is our first solution. So we'll give ourselves a little check for that. And then just substituting that into one of the equations. So sub in y equals 3 into, just try to see if any of the equations are easier. I think the numbers are lower in equation 2, so we'll sub it into equation 2 this time. It's just trying to pick out the equation which looks like there is less chance of making a mistake, basically. So here I kind of avoided the negative. Negatives tend to be more difficult. Here the numbers are just higher, so we're going to go for equation 2. So we get 5x plus y, but we now know the y value is 3, so it's 5x plus 3 equals 13. Moving the 3 to the other side, beside the 13, we get 5x equals 13 minus 3, which is 10. Dividing both sides by 5, and we get 2 as our second solution. So that's that one done. So again, not too difficult, but really it's quite a lot easier because these guys were already matched up. If we turn to the third example, those are not matched up. So the process is largely similar once you get going, but what you need to do in these equations, which we're not going to fully develop, but what you basically need to do is to create two new equations, equations 3 and 4. And in equations 3 and 4, you're going to choose to get the x's or the y's matched up. Once you've got to that point, then you'll just subtract or add your equations again, just like we did here. And then this flow of algebra will just be the same down here. But it's this missing step here that we're not going to chat about in this class. That's probably where you'll be going to with simultaneous equations. If you're starting this topic, you'll start here. Fairly quickly, you'll master these and you'll move on to these more difficult scenarios. So if you've already done equation solving in the past, if you're already quite comfortable with algebra, then that's not the most difficult technique, but it's quite an important one. It will come up in a lot of math classes in the future, and there's a graphical interpretation of these. So these are actually the equations of straight lines. So when you find a solution, x, y, what you're actually finding is a point on a line, because if you've already done straight lines, you'll know that they're in the format y equals mx plus c in their equations. This is the equation y equals mx plus c, but jumbled up, but it's still a straight line. That means that lines 1 and 2 go something like, potentially something like that. So let's say that's line 1, and this is line 2. If you're trying to find a solution xy, which is just a point on that line, and the same xy solution on that line, well, that's a point which lies on both lines. The only point that lies on both lines is the point of intersection. So when you're solving simultaneous equations, what you're actually finding is an xy pair, in other words, a coordinate of where the two lines meet. So that's another thing that needs to be developed within this topic, is a graphical interpretation. But I just wanted to add that in at the end there to kind of round out your knowledge a little on simultaneous equations.